So let's go ahead and get this program started. Wow, this room is full. I've never seen it this full. My name is Leif Vidito. I'm a vice president with Silicon Valley Bank. Very pleased to host the MIT Club of Northern California and help provide the space to put this on. It is, I suppose, no surprise that this room is this full, given the Tesla story. It's very exciting, and I know that I'm excited to hear the insider account from Mark. So just a very quick word about SVB. We're a full-service commercial bank, solely focused on the technology community. We work with companies of all sizes at every stage in the tech community. I'm solely focused on the clean tech sector. Work with companies from venture-backed stage all the way up through public companies, so long as they're somewhere in the energy, industrial, technology space. But you didn't come here to hear about SVB, so I'm going to turn this over to Larry Kelly, who's going to kick the program off. Thank you.
Thanks so much. Thanks so much, Leif. So, I'm sorry, Mark left. Oh, he's coming back. All right, okay. Good evening, fellow entrepreneurs. A great evening, and welcome to the first of the inaugural session of our new series, Pioneers in Energy and Clean Tech. The club has had many activities in many different spaces over the years, and Doug started the Energy and Clean Tech series 2-3 years ago, and we got together and we were talking about it, and we realized that there's another part of this, the pioneers in clean tech, and that's what we're focused about on this series. This is the first session. The club alternates, as you know, between events in San Francisco and down here in the Valley, and we decided in terms of kicking this one off that we would have the event twice. So we had it last night, as you know, in San Francisco, and again tonight, and it's sold out in both locations. So there must be tremendous pent-up demand, or we're all on the same wavelength, and it's just really great. Thank you so much for coming out tonight and for all of your enthusiastic support. The focus is on entrepreneurship. So if I could ask a question, everybody in the room, if you could raise your hand. Right, so everybody, put your hand up. Right, okay. All right, everybody, get some blood flowing, get some oxygen to the brain. Get your hand up, especially you. Right, okay. Yeah, I know you. Right, okay. Now keep your hand up, unless you're not an entrepreneur. If you're not an entrepreneur, put your hand down. Okay, to keep it up if you're an entrepreneur. We got up if you're an entrepreneur, down if you're not. Okay, this is great. This is phenomenal. This is the audience we want. So this is a much higher percentage of entrepreneurs in this room than there are in the general population, and that's what this series is all about. We live in this wonderful place, our valley, and we've had wave after wave of great entrepreneurship, and it started way back, in the 1930s and 1940s with defense. We had companies like Lockheed and Hughes Aircraft, and some of us, not me, are old enough to remember the Spruce Goose, that flew out from Moffett Field and NASA and so forth. And then the next wave after that was electronics with Hewlett-Packard and Varian and some of those companies. And that was in the 50s and 60s. And then in the 60s and 70s, we had the first wave of computers, semiconductors and computers and enterprise software. And that went later to personal computers and LANs and personal productivity software. And then we had the next wave, which was wide area networking and internet and the dot-com era. After that, it was where we are now, which is smartphones and tablets and social, local, and mobile software. And you can see this trend, and you can look out and you can see that the next wave is going to be wearable computing. And somebody out here has Google Glass. There's somebody here with one of those, and I don't know where he is, but there he is. Yeah, right. Yeah, so you know what's happening. And the next one is right in here, right? And so that's one wave, and we had these progressive waves of great entrepreneurship, building great and enduring companies. Somewhere about 35 or 40 years ago, we took another track on the side, and we went off into life sciences and biotech and medical devices, and we've had some great companies in that space. Genentech and Applied Bio and now the gene sequencing companies, and they're doing really well. And then about 15 or 20 years ago, we started in this energy and clean tech space. And what we've learned is that the space pervades all of our economy, every industry in our economy. And, everybody uses energy for something. And so it's vastly multidisciplinary and has impact on every technology that we use. In fact, some people are beginning to call it main tech. So maybe we should call this pioneers in energy and main tech, right? How many read Eric Westhoff's column? He's the editor of Green Tech Media, right? You know who this is, right? Okay, so Eric is really right on. You should read his column, Green Tech Media. He has great insight on both sides of many of the issues in this space. And for years, he's been saying in venues like this, he'll get up here and he'll say, could someone in the audience name a successful energy or clean tech company? And it'll be like this, right? Be quiet. Well, so now we have some successes in this space, and that's what this series is all about. Is what we'd like to do is present several successful several successful companies in the energy and clean tech space through the eyes of the energetic, unstoppable, scrappy, and resourceful entrepreneurs, and we have one of those here tonight in Mark, and that's the operative phrase here in this definition. Without regard to resources currently controlled, right? Scrappy, resourceful, go out, make things happen. So, so I grew up in Detroit, and I was in Detroit in the heyday of the automobile industry during the 50s and 60s, and I always wanted to have a hot car, and for a while I had gasoline in my veins and worked in a number of automobile factories. And if you had come to me, several years ago, or as recently as 4 or 5 years ago, and said, now remember, we haven't had a successful car company start in the United States since the 1920s. If you had said, well, we're going to have a successful car company soon, you would have been met with, eyes of disbelief. And yet here we are, we have Tesla. And it's a great story. And Mark is going to, our energetic, resourceful, scrappy, unstoppable entrepreneur is going to tell us about that. Mark is local boy, grew up in Sacramento. His favorite hobby is driving his kids around. In which car?
Oh, a Tesla.
The Tesla. Yeah, there you go. And he graduated from Berkeley in 1985 with a degree in CS. And we're not going to hold that against him. And besides, they're not on our football schedule. So Mark worked in Saudi Arabia for a while and worked for a number of startups here in the Valley in areas like embedded systems and sensor networks and facilities automation, all of which laid the groundwork for some of his subsequent work. In 1997, Mark teamed up with Martin Eberhardt and started Nuvo Media. Nuvo Media pioneered the legal and technological framework for digital distribution of ebooks, and along the way launched the Rocket ebook. Nuvo Media was very successful. They were acquired by Gemstar TV Guide for $170 million. So that's one, right? Good acquisition, good exit, right? And then a few years later, 2003, Mark teamed up again with Martin and started Tesla Motors. And well, here we are today. So one of the things I'd like you to do, everybody who put their hand up, and if you didn't put your hand up, it's okay, you can put it up now, right? Be an entrepreneur. Put yourself in Mark's shoes as he talks through the story of Tesla. Think about, what were the decisions he had to make? How did he get resources available? What risks did he take? What risks did he get somebody else to take? And what decisions would you make at each of these various points in the development of your company, right? So our energetic, unstoppable, scrappy, and resourceful Mark.
Thank you, Larry. And if you could bring up my slides.
Right.
I'm going to outsource this to Larry to bring up my slides.
There you go.
And do I have a clicker? I forgot to get one.
Do we have a clicker? You may, I think you may.
Test it, make sure it works.
No, it does work. Maybe not. You want me to stand here and click it?
Yeah, it's all this IT stuff. Well, oh, great.
Figure it out.
So how many MIT engineers does it take to,
It's not, you know. Not on our football schedule. I'll stand here and do this. How's that?
yeah, I can, is it really not gonna work?
it's these two, right?
Right. Okay, I can do it. All right. So as Larry explained, this was our second company. Actually, Martin had one company even before that was also successful. So he's actually done the hat trick. He's done it 3 times. But in 2003, Martin and I were trying to figure out what to do next. Now, we had done the electronic book when it was hard. That's like a really old version of an iPad. When this kind of technology was hard. We had seen disruption coming in with the internet. We thought we could make a difference there. We literally looked around for a variety of different things we could do and said, we both like to read. We'd like to meet lots of interesting authors. We'd like to know about how publishing works. Let's do electronic books. It was kind of ripe for disruption. We had a great time. We met interesting authors. We figured out the publishing, the fascinating world of publishing, which the companies there are hundreds of years old, and some of the same people are still working in those companies. Change is almost unheard of. So it was a great sort of run-up for the car industry, really. But we wanted this time to do something that had a little bit more meaning, because although it was really fun with electronic books, we wanted something, something that actually had a little bit more behind it. So we looked at these big problems, and there are lots of big problems out there. We're going to be in this very interesting age, but the one that we took was oil. Now, you think, well, of all the things, oil, I mean, my God, but it actually is neat because it causes all kinds of problems. So if you can reduce your dependency on oil, everything gets easier. There's an environmental aspect, there's a political aspect, there's a national security aspect, and there's a resource depletion aspect. And all of these things get better if you can get off of oil. If you look at oil, like where we use it, it's transportation. And within transportation, it's really cars. We're not going to make electric jets. I mean, that's just not going to happen. But I want to use the last drop of hydrocarbons for jet fuel, because I love flying. So that's super important. But when we started this, I am a computer science person, Martin is an electrical engineer. We were pretty sure that electric cars were going to be the answer, but we weren't really sure. We wanted to absolutely make sure that we weren't going to get blindsided by something, that some other technology was going to come along to get us off oil that knocked us out of the market. So we did quite an extensive analysis, and there was lots of possibilities. And at that time, hydrogen fuel cells, I don't know if you remember, there was these wacky books, like the hydrogen economy, and everyone was going to sail away. And even, there was an estimate in California, we would put in these hydrogen freeways, and it would only cost $1 trillion or whatever to do that. But then, the energy would be free. Because hydrogen, as everyone kept telling us, was the most abundant element in the universe, so it was perfect to use as a fuel. It's really seductive. You put hydrogen in, you put it into a fuel cell, you get water out, and you get motion, you get electricity out to power the car. The problem is where does the hydrogen come from? Because, in fact, hydrogen on this planet is totally bound up into everything we have. It's not in free form. There are no hydrogen mines. You have to make it. And how you normally make it is with electrolysis. Now, I know there are other ways of doing it. You can strip natural gas, for example, but now you're using another fossil fuel. You can also get it from algae. And in fact, somebody just sent me another article, a couple weeks ago. Actually, it was my wife, on algae, producing hydrogen in this new breakthrough. And I showed her the various breakthrough algae slides we had from 2003 that was said that hydrogen was going to be the fuel of the future, any day now. And it will always be the fuel of the future because it just doesn't make much sense. So you take water in and electricity, and you make hydrogen, and then you put it back through the fuel cell, and you get water, electricity out. And it doesn't really matter where the electricity comes from. So the question was, maybe that's a great way of doing it. And hydrogen fuel cells were getting money. So if you're in the funding world, if you're looking for financing, the VCs were funding hydrogen fuel cell work. So he said, well, how many miles with 1 unit of electricity do you get? And I don't care where it comes from. It can be dirty or clean. This is a misnomer we ran into constantly. People would say, oh, it doesn't matter how efficient it is because we'll use solar panels to generate the electricity. Well, if it really is terribly inefficient, you're going to have a lot of solar panels. Any resource that you're going to use, you want to use it as efficiently as possible. The efficiency is going to win. So we looked at this and we said, well, if you take a megawatt hour of electricity and you use electrolysis, which can be 70% efficient, and then you compress it, because you got to compress it to make it useful, and then you distribute it. And hydrogen turns out to be really hard to distribute. So we couldn't figure that out. And we just said, well, let's just assume you make it right there on the site with the car. And then you put it back through the proton exchange membrane fuel cells, which are, for a variety of reasons, kind of the only type that are used in cars. They're theoretically 40% efficient. I think the highest measured one's about 27%. And you can go about 1,440 miles. But if we knew from the consumer electronics industry that we could just charge up lithium-ion batteries and then discharge it with existing technology, and we could go 3 times further. So right away, we knew that hydrogen was not going to be a threat to us. It required an incredibly new, vast infrastructure, and it was 3 times less efficient than just using a pure electric car. Ethanol, very big at the time. We thought maybe that would be the solution to the oil. And you can take it from biomass, and there's lots of different biomasses, and you can actually go a long way if you work it out, and you have really great. If you listen to all the proponents of the various biomass fuels, and there's a lot of reason to do this for other reasons, not for cars per se, but you go about 2,500 miles per ton, and that's really optimistic, but you might be able to get there. And then we thought, well, that's pretty good, but what if you just took that ton of biomass, whatever it is, a bunch of wood or whatever, and you just burned it? You didn't use this fancy new stuff that people were investing in. You simply took it and you just burned it in an existing General Electric generator that you can buy off the shelf and charge an electric car. You could go twice as far. So again, we thought, well, that's not going to be a threat to us. Ethanol also comes from corn in this country, the only country that would ever consider doing it with corn. We have a very robust corn lobby. And assuming that I'm doing this right. Assuming that it is energy positive, you get about 2,300 miles per acre in corn. Now, this is assuming it's energy positive. So these numbers are from the corn industry. If you actually look, a lot of people say it's energy negative, that the more we grow and the more we do this, actually the deeper the hole is that we dig. But we thought, well, 2,300 miles per acre, maybe that's okay. How much of the land in America would that take to offset our driving? So we went to the CIA website, because they have all these great statistics, and they said that's the amount of arable land in America. That's all the farms in America. That's how much it is. And if you planted it entirely in corn, using the corn industry's numbers, you could offset half the driving in America. Now, we would be importing 100% of all of our food, but we would not import nearly as much oil. This did not seem like a winning solution either, despite the corn lobby's rather insistence that it is a great idea. So we then thought, okay, Vinod told us that we were barking up the wrong tree. Vinod Khosla, a great entrepreneur as well. And he was investing a lot in ethanol production through Macanthus, which is a switchgrass, is what it's frequently called, and then using enzymes to actually do the ethanol production. Way more efficient. And if you do the same calculations, it comes out to about 51,000 miles per acre. It's hugely energy positive. There's no question about that. So if you look at that, you could take an acre of, if acres are really what you're trying to measure here, you could take an acre of desert land and you could drive 32 times further by just putting photovoltaics that exist today. And you don't have to use enzymatic processes that have never scaled to these levels or are getting these kinds of efficiencies. But it still might be a good idea. So again, if you go back to the land, you look at this and you say, well, what would it take with Macanthus? It's still like 20% of all of our food production has to go away. in order to offset half the driving in America using an enzymatic process which has never scaled. And that, by the way, is how much land we'd need for the photovoltaics, but it's in the desert. And that would completely, it's 50% of all the driving in America. Another way to look at it is it just pollution or energy from, you're just simply moving it from one place to another. So we thought, what if we charged the car with coal? If we really had a coal-powered car. And it turns out coal plants come in sort of two flavors, old and modern. The legacy plants are incredibly inefficient. They only convert about 27% of the energy in the coal to electricity. It's just a disaster. And we still have quite a few of those. They're built in the 40s and 50s. So if you had a totally coal-powered car and you work out the energy equivalents, you can see that legacy coal actually is still better than sort of a 45 mile per gallon car, a gasoline-powered car. It's still more efficient if you take that coal and power an electric car with it. Now, you wouldn't really do that. There's no utility that uses exclusively legacy coal. So realistically, they have some mix of newer plants. And then, of course, natural gas is much more efficient. You get about a modern natural gas plant is 60% efficient, converting natural gas energy into electricity. So we felt, okay, that's good. So no one's going to be able to attack us on that front. And actually, people did. We had lots of editorials saying, electric cars are stupid because it's just using coal energy anyway, and that's way less efficient, and that's really awful. And we had all the numbers to back us up. We actually had these white papers we put on the website to defend ourselves against that. And the really cool thing, of course, about electric cars is that you can get the fuel, you can get the energy from anywhere. Once the electrons are on the grid, it doesn't matter how you made it. So you can obviously not use fossil fuels at all. So these are the equivalents of this particular array. You get about 360,000 cars of driving a year from that. And this is one in the Mojave. This is one of my favorites. This is Germany has more photovoltaics than any place else, and it has no sunshine. And so this is like a typical shot. The guy's in a raincoat and he's out there, buffing up the solar panels, and but it still produces enough power for about 4,000 cars. I mean, if we had those in California, it'd be way different. And different parking structures. This is really close to here. I've ended up parking under it. The cool thing is it scales all the way to individual choice. So if you want to think about it, that is what it takes to drive about 12,000 miles, which is the average in California, per year for your car. It's 3 kilowatts in California. Obviously, if you lived in other parts of the country, you might have to have a bigger array, but we get a lot of sunshine here. But that's all that it takes to be completely energy independent in terms of your transportation. And I think that's really compelling because there's an enormous infrastructure for oil that goes all the way back to the sands of Saudi Arabia, where I worked and lived for years, and has embroiled us in all kinds of stuff. And that's really what it takes right there to not do that. And that's Martin and his car and the array on one of his houses. So at the end of this analysis, we were convinced that no matter how any competition would come at us in terms of efficiency or pollution or land use or whatever, we could defend it. In fact, not only could we defend it, but we had the best numbers. In fact, they would be on the defensive. So why aren't there any EVs? Now, this is 2003. And we're really curious about this because we think it's so obvious. Now, the electric cars in 2003 were not doing well. And nobody was buying it. And there were these articles we'd read about it and said, no one buys these things. Electric cars are stupid. No one's ever going to buy them. And would anyone buy these things? I mean, this is, why Martin coined this term. He said, these are punishment cars. They're designed by people who hate the idea of driving. And the only time that you would ever, but if you absolutely had to drive, you should be punished. And they designed those things. But there were electric cars that existed before that. In the 90s, California created what was called a zero emissions mandate, which required that if you were going to sell cars in California at any volume number, you had to have a certain percentage of zero emission cars. Now, there was all kinds of reasons why the law was not very well thought out. But incredible, isn't it? I mean, from Sacramento, regulations that weren't well thought out, but it was the case. And all the car companies eventually were forced to produce some kind of electric car, with the EV1 from GM really being the best of the breed, although the RAV4 EV was really quite nice too, and there's still quite a few of those original ones around. And everybody else kind of just did a lame job of throwing some batteries in the trunk and calling it good. The moment that they successfully got the zero emissions mandate rewritten, literally the next week, every single one of these was out of production. And furthermore, the GM group, of course, quite famously, because you could only lease them, they took all those cars back and they crushed them. They even took ones back from that they had on display. So there was some in museums that they took back and crushed. They wanted no reference that this thing had ever existed. And there was a great quote that we used to have up on the wall from, there's a new auto wing in the Smithsonian, and GM put a lot of money into that. And one of the conditions was that they would not show an EV1. And when asked about that, they said, museums should be about the future, not about the past. And you know, I kind of like to beat up GM, but it's hard not to. I mean, it's hard to make these things up. Anyway, so, but they had a really compelling car, and yet, you know, that they crushed them all. And they simply said, you know, there just wasn't enough interest. You know, there was no long-term business there. It basically never appealed beyond a limited number of tree huggers and geeks. And you know, that was it. That's not a market. So we looked at, well, who was their customer? They had these things. We have existing databases of this. One of the neat things about cars is because they have to be registered, that data is public. So you can find exactly what zip codes, you know, had these cars registered and sort of almost who drove them. It's really, really great that way. It's unlike most consumer products. So we discovered something really interesting, that the average income of the people who were leasing the EV1, despite the fact that the lease was quite reasonable, was over $200,000 a year in '97. The only time that GM has successfully sold into the very top socioeconomic group in the richest state of the Union, they of course then took them all back over the dead bodies of their lawyers and crushed them, and then wondered why nobody was buying their other cars. But this was really interesting because, you know, that's a really great group if you want to find some early adopters. The Prius had come out a couple years before, and it was eating into Lexus sales. Now, Toyota had designed the Prius on the I think it's the Echo platform. It was their absolute cheapest, lowest quality platform that they sold in North America. And I'm not exactly sure, there's a whole lot of supposition as to why they released the Prius and how they did it. But their target market was sort of people who were real miserly that couldn't do math very well because it was never going to pay for itself, but these people just didn't want to spend any money on gas or, you know, whatever it was. And it immediately started losing Lexus sales. And this was a real problem because they had negative margin on the Prius. And of course, Lexus was their cash cow. They had the highest margins. And the reason why, and you know this is true if you just think about where they were. If you're in Palo Alto, every driveway had a Porsche and Prius. Right next to each other. And this was at a time, this was at a time when gasoline was $1.50 a gallon. It was essentially free. In real dollars, it had almost never been as cheap as this. And yet, people who had lots of disposable income were buying electric cars and were trading in their Lexus to buy, you know, essentially a car that would have been $14,000, but was more because in order to save gas. Clint Eastwood very famously bought a Prius. He didn't do it to save money. And this is the really important thing. We discovered that the value proposition for the customers of these cars had nothing to do with saving money. It was about projecting doing the right thing, projecting their image in whatever the right way was. For them. And you know, I don't know exactly what it is they wanted to say, but one common feature is they didn't want to use oil. So, you know, Clint Eastwood, probably for national security reasons, he's a national security hawk. The former George Shultz driving around in his Prius. Again, you know, he has a beautiful place in San Francisco. He can easily afford any car he wants, but he was driving a Prius because he didn't want to contribute to that oil economy and everything it represented. So this was really important from a marketing perspective, that it wasn't about saving money. And we continuously fought this. In every investment meeting, one of the VCs would say, when will the sports car pay for itself? And we would always say, what sports car do you have? And they would say, oh, I've got a turbo GT, blah, 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 because all VCs have sports cars. And I said, so when will that pay for itself? And they'd go, oh, no, it's different. It uses gas. It will never, For some reason, that was different. Anytime people had disposable income, they upgrade to a nicer car, and they project their values with that. So the other thing that we knew was that batteries were getting better. And we had lots of quotes from the car industry, as they all got out of electric cars. Every single one said electric cars are not possible, and the main reason is the batteries have not gotten better in 100 years. They had these great graphs that showed just total flatline from about late 1800s to now. And that was true for lead acid batteries, completely true. But in consumer electronics, we had never used lead acid batteries. We started with NiCad batteries. Then nickel metal hydrides came out, and they were a big improvement. And then lithium-ion batteries. All along the way, every year, the energy densities were going up, the power densities were going up, the price was coming down, and this is exactly the kind of thing that other industries don't see. We see this in the consumer electronics world. And the thing on top of it, which we loved, was there was enormous commodity pressure. They were making lithium-ion cells by the billion. And there was many, many factories all competing for the best possible performance characteristics at the lowest price. Everyone wanted more camcorders. Everyone wanted more of everything. And in fact, we had trouble getting them, and I'll tell that story. I'll tell it right now. So as we were looking at batteries, there are, we're just a couple guys, and we wanted to buy a whole bunch of batteries. They didn't want to sell that to us, basically. So we would take the salesperson, and we'd say, so what is your ideal customer? How many cell equivalents would your ideal fantasy customer own at any given time? And they said about 7. That they had 2 in their laptop, and they had an extra, and 2 in their camcorder, and an extra battery, and 1 in their cell phone. And we said, well, each one of our Roadsters will take 7,000 cells. We think that you've underestimated your market by a factor of 1,000. Not 10, but 1,000. And they would kind of think back on that and disappear. And if you tell even a lowly salesman here in America that, you will get a call from the very top of corporate Japan saying, what do you mean about this being 1,000 times bigger market? It's really fascinating. It really does work its way up. And that's how we were able to work with the battery suppliers. But we had to figure out what kind of product we could make. So we had some advantages. The EVs, of course, are most efficient. They're also super quick. For all the electrical engineers here, you know that electric motors have maximum torque at 0 RPM. And they maintain that through an incredibly long RPM range until they drop off at constant horsepower, basically. You get current limited. This is a big deal. It means that you could have sports cars that perform like nothing else has ever been possible. So and it turns out from our marketing studies, we knew that people paid for that. That whether you liked it or not, there was lots of people that liked quick, fast cars and were willing to buy them, at great cost. So there's all kinds of challenges. There's no infrastructure. There's long charge times. So we did some marketing studies and determined, and marketing studies, we asked a bunch of people we knew, and we said, when do you begin to get nervous about needing to get more gasoline? And it turned out that people begin to kind of think about getting gasoline when they have about 50-mile range. So like the EV1 had a 50-mile range, which meant that from the moment you got in, you were panicked, right? That's, so we said, well, this is, we have to do something way beyond that. And we looked at people's driving patterns and it looked like about 200-mile range. And if you look at that and you say, well, what will that take? You don't have to do much analysis. You just sit there with the spreadsheets and you can say, well, here's the energy density and the power density of these cells, and this is how much it's going to weigh, and we want this kind of performance. And you sit there with high school math and high school physics, and you can model the car fairly well in a spreadsheet just using Excel. And we came up with this. And these specs, we figured we could get under 4 seconds acceleration. Now, At that time in 2003, that was supercar. I mean, the best Ferraris and stuff were really coming in right at about 4 seconds. The sub 4 second threshold, that was what kind of everybody was after. So we figured we had to make it better than what the gasoline cars could do. So we wanted, or at least as good as the very best gasoline cars. So we came in about 4 seconds. Greater than 200 mile range, very, very efficient. So of course, Silicon Valley, we immediately incorporate. We kick off a design study using lithium-ion cells with a company called AC Propulsion. They had been consulting to the car industry for years on electric cars. When the zero emissions mandate was changed, all their contracts were canceled the same week that everything else went out of business, and they were, kind of hurting for business. So we gave them some money and said, use these lithium-ion cells they have a prototype car called the T0. It's kind of like a plastic little go-kart thing. And they put the cells in, and they worked like magic. We wanted to make sure that we hadn't overlooked something in the engineering. We also then borrowed that T0 for fundraising. And in fact, that's the former director of the CIA, I think, in that. We had very interesting people that wanted to see it. And that actually turned out to not work so great. The VCs don't have a lot of imagination. I don't know if there's any out there, but just in general, guys, you don't have a lot of imagination. So I like to bring props and show things to people. And we showed this car, and we thought this was great, and it really backfired for the most part. They kind of got that you could accelerate quickly and stuff, but they couldn't get past the fact that it looked like a go-kart, and it was this bright plasticky yellow, and they'd say, I don't want a yellow one. It's like, no, this is not the car. This is really, this is just to show off what's possible. And AC Propulsion was great about letting us borrow it. So we also kicked off some partnership studies. My big concern was how to make the actual car. I was convinced, electric motors have been around for 100 years. Nikola Tesla invented the AC induction motor, which is what we had designed in 100 years ago. Software, silicon, that's what we do here, right? That's not going to be a problem. The car thing kind of freaked me out. I was like, Martin, how are we going to do this? But the more we researched into the car industry, we realized that about 30 years ago, they had started completely refactoring the industry. And they had outsourced everything that wasn't their core competency. And it turned out what they kept was the development of the internal combustion engine itself, the development and manufacture of the engine, not even the electronics, because electronics, that was stupid stuff that other people could do. So the engine control computers, they didn't even do those. But they manufacture these incredibly complex mechanical devices very cheaply and with unbelievable reliability. It's almost impossible. And that was their core competency. They also kept marketing and a little bit of design and nothing else. Everything else they outsourced. And so those same suppliers were available to us. In fact, they generally kept the final assembly, but even some of that was outsourced. In Graz, Austria, Magna Steyr makes lots of cars for car companies, including the BMWs and Saabs at the time, and the Jeep, the European version of the Jeep Cherokee, entirely outsourced. Those car companies they have nothing to do at that plant. They just make those on those lines. So we looked around, and for our particular cost structure and size and vehicle, it turned out that Lotus in the UK was a great partner. Lotus also had a history of making small volume cars profitably, or at least semi-profitably in their case, but they kind of made it work. And it was a good impedance match for us, and they had done this before. They had a group that did nothing but contract manufacture. They made the Opel Speedster and some other cars along the way. We created a business plan, the very last business plan on paper in Silicon Valley, because that was, now it's all just spreadsheets and slideware. And we went to Sandhill. Now, the word clean tech didn't exist, and we thought, well, this is going to be really hard. It actually wasn't as bad as we thought. We did a couple of things, I think, quite smartly. We knew a bunch of VCs that were never going to invest. I mean, most VCs aren't going to invest. We knew some that would really never invest. And we asked them if we could pitch to them this goofy car company idea we had, knowing that they couldn't invest because their funds only did, biotech or whatever. But we wanted the feedback before we shot our silver bullets with the real people that might fund us. And that changed our business plan. The questions that they asked, and we got their full attention, because some of the best was there was a VC fund that really only did optical routing. And imagine if you're those partners And every day, it's just optical router startup after optical router startup. And so we had the entire partnership for lunch, which was like, we expected the one person we knew, and everybody was there and gave us some great feedback. And through that and some of the other VC interactions, we actually changed our entire distribution model, and they made some great connections for us. And then we went out and started really looking. This is in January, and then by March, we're actually on Sand Hill Road with people we think might actually fund us. We pretty quickly convinced 2 small VC funds because there was only 1 or 2 partners to convince, so that worked great. And we found Elon Musk, who was an angel investor. And we were kind of right up his alley in that he was really worried about the energy equation of the United States. And he really wanted to get some way of getting us onto a sustainable energy path. And part of that is, what we use for oil. So we pitched him, and he was in. I mean, almost immediately. And he was very busy building rocket ships, which is the most astonishing thing possible. I mean, I don't know if anyone is familiar with SpaceX, but I think it's the most amazing achievement of any company out there, because that is really, there's a reason when people say, oh, well, that's not rocket science. Well, everything they do there is rocket science. And he's able to do it at a fraction of the cost that the incumbents have been able to do it. So we were off to the races. We had money. We started some styling studies. That's JB Straubel, one of our first employees, who's now CTO, one of our manufacturing guys who was with us for years. We moved to San Carlos, our first building. I love Silicon Valley. Silicon Valley is the only place you can do this kind of stuff, I think. We were able to get this building. We were able to get the first building, the first little office we rented in Menlo Park, by just showing up, and they didn't really ask anything, and we just gave them 1 month deposit, and we were there. This building, they said, well, are you venture funded? And we said, well, not really venture funded, but we do have some money because we had this angel money. And they say, well, okay, sign the lease, and can we get shares? As and no, we don't allow that, and we're done. 2 years later, with $30 or $40 million in the bank, we were trying to rent a small office in Detroit, and almost couldn't do it. The building had been vacant for who knows how long. It was free by our standards out here. We could have bought the building for what we paid in rent here. And they wanted 10-year financials. They wanted projections out for another 10 years. It's a 1-year lease. The building's been empty for years. It almost wasn't possible. It took us, I was negotiating that stupid lease for weeks and weeks and weeks. And then the best part is I finally disclosed I thought the $30 million in the bank would do it. And I finally had to disclose some projections. And he says, you're going to run out of money in like less than 2 years. And I said, oh, we're going to run out of money way before that. But eventually we did get the tiny little office we were trying to get. We also picked up a mule. And in the car industry, mules are very specific things. What you do is you can take one car, and you take some parts from other cars, and you take some technology you're trying to test out, and you put it together in this sort of funny platform, and you drive it around. It literally is a test bed for the stuff you're doing. And the reason it's called a mule is because it doesn't reproduce. There's only ever going to be one of them. From the very beginning, it's not what you're doing, you're testing some piece of technology. So we were able to get a Lotus Elise that got stranded here due to emissions reasons. And Lotus, by this time, we were in pretty good terms with them. And we began designing the drivetrain. This is us putting the battery pack in. The battery pack, it's all about the batteries, really. And we had to really understand how to make the batteries work and be safe and age well. So we started there because that was the biggest risk. We wanted to retire that risk first. So we did the battery pack, and then we bought an inverter and a motor from AC Propulsion to power the car. Meanwhile, we were working on those designs, but the battery was really the first step. We had a beauty contest with stylists from stylists all over the world, which was fascinating. We had a great advisor. We gave all the stylists the same information, and they came back with these drawings that were terrible, And our actually it was Bill Moggridge from IDEO looks at these and he says, "What did you tell them?" And we gave him our package, and he nods and he walks off. And about a day and a half later, he calls and says, "We need to meet." And he had created this presentation, which I didn't understand. Martin kind of got it. It had these pictures of cars and little sliders, and it would say feminine, and you'd slide the little thing over, or curvaceous, or modern. And it was in design language, and we slid the little sliders. We finally kind of got it after the second or third time. He went and then gave the package to all the designers, and they resubmitted designs that were right on. And it was fascinating, because they didn't understand a word we had said. As engineers, we thought we were perfectly clear what we were looking for. So we had these, and we picked Barney Hatt, who happened to work for Lotus, although he didn't need to, it just happened to work that way. And they started doing it in clay. Now the stylists do a funny thing in the car industry in that they switch to clay. They draw it out by beautiful little drawings, and they go to clay. And at this point, by January, we now have the mule ready for the first drive. And we had it the night before the board meeting, like really late at night, or maybe even the morning of the board meeting, quite early, I'm not really sure. And we drove it around in the right for the board, and the board got in it, and they got to drive around. And that was our first milestone. Now, any entrepreneur here knows exactly what you do when you meet your first really, really big milestone, and that is you raise money. Because you now have retired risk, and you can get a better valuation, and you probably are over budget and stuff, and you're going to need money right away anyway. So Series B got funded. Everybody came in, and we picked up some new money from Chicago. We opened an office in the UK. Fortunately, at that time, Lotus was not doing too well. They had a bunch of empty space, and we were now working quite closely with them. We continued the packaging studies, and we started the full-scale clay. Now, objects are kind of funny. They're not totally linear, so you have to sort of see it in real scale. And this is the final full-scale clay. That is clay. So, and they put this kind of mylar finish on it, because unless you can see the reflections, you can't see the contours of the car very well. If it's just flat like that, you can't figure out what's going on. So they wrap it, and they sort of shrink wrap it, and you look at it, and then they peel it all off and sit and cut and stuff. And the other side is very different. They were trying different styles, and you get one side the way you want it. Then they digitize it, and then do a mirror of it, and then at that moment you are set. You're totally in the CATIA, CAD world from that moment on. You beam the files to one of the many different aerodynamic car testing houses around the world, which again was something that couldn't happen 30 years ago, because those were all owned, they were captured by the car industry, or by the car companies themselves, the OEMs. They outsourced all of that, so we could find the best bid, literally we FTP'd the files. They take a giant block of plastic in a 5-axis milling machine, and they can make a giant SUV in like 3 hours that way. This probably took an hour, and they make this beautiful plastic full scale, and they put wheels on it. And one of the funny things is that you have to do that for aerodynamics, because aerodynamics are nonlinear, so you can't test in small. You got to do it in the full scale to really get it right. At the end of it, I thought this was so cool, and I said, we want that. Can you ship that back to us? Actually, I think Martin may have said that, and I was like, okay, I'll figure out how to do it. And I call him up, and I say, we want the Aerobuck back. And they said, no, it's just plastic. It's just an Aerobuck. We'll just put it in the shredder. And I'm like, no. We want it back. We want it here. It's going to cost thousands of dollars to put it on a ship. We'll just put it in the shredder. No, and we finally convinced them they'd never had anybody want the things before. And we had it in a lobby for years. In fact, I think it still might be in one of the lobbies somewhere. It looks like the Batmobile, because it's this matte black. We also decided that we were going to have to make our own motors. Now, this was kind of a shock to us, because we were planning AC induction motors, 100 years old. They're in everything you've ever plugged into a wall that spins. So we thought hundreds and hundreds of factories all around the world, no problem. We needed one that had very high efficiency, very high power density. It wasn't that hard, really, to design conceptually. No one was willing to do it for us unless we completely paid for all of the tooling, did all of the design, paid for all the design, paid for all of the tooling, and then allowed them to sell it to whoever they wanted to. So at that point, we decided we would actually make our own, which was a little of a distraction, but not so bad. We started work on another mule. This one was going to look like our final design. Remember, the other one looks like a Lotus Elise, and was really just about some piece of the technology. And by January, we had a beautiful car, really. Everyone could see it. Now, we're still stealth. Nobody really knows what we're doing except some of the investors. At that point, we're ready to build real cars. And so there's a point where you put the pencils down and you say, everything is production intent. This is what we think we're going to build. And you build some. You don't do it in production process. Every part is, sort of milled or whatever, because you can't afford the tooling because you might change everything. So this is the EP1, Engineering Prototype 1 coming off. We built 10 of them, one right after the other. And by May, it's out the door. It is gorgeous. The fit and finish are pretty decent. It drives. It took, everything we had to make it move, but it did drive. So of course we immediately raised more money. By this time, the word clean tech is getting out there. There's funds that have carve-outs for clean tech, and we raised a bunch more money. And we had something beautiful to show. We had retired a lot of risk. EP1 was using all of our electronics, all of our motor, all of our battery systems. I mean, it was our production intent vehicle. We then publicly launched, which is a big deal in the car industry, how the image of the car is revealed. And they have these really funny disguise systems for cars. Because if a magazine gets a spy shot of your car, it can ruin your launch. Other magazines won't allow it in the magazine as a launch. So they have these like suits you put on the cars if you want to drive them out in the public that they make it look like a dinosaur. They have these big, giant styrofoam blocks and stuff. They're really goofy. And I said, this just can't be. And I looked, and sure enough, there's all these spy shots of these various cars. But they just look completely insane. You can't tell what they are, which is the whole point. So we had a big shindig in Santa Monica. We got a lot of pre-orders, which is a story on itself. We kept finding, as we were looking for investors, and many of them would say, gee, I really love what you're doing. I want on the list. And we kind of jokingly said, well, write us a check. And people started to say, okay. And then we said, wait, we're not kind of set up for that. So we decided to actually take quite a lot of pre-orders. And at that time, we took $100,000. We took the whole amount up front. And it was surprising how many people were willing to write the check for a company that had never delivered a vehicle yet. But that worked out. We were very careful to sequester the money and not, spend it before we were actually in production. But it was really a really interesting experience. We also crashed some of these very, very expensive prototypes. Now, the crash tests, again, completely outsourced now. The big car companies don't have any of these facilities themselves. In fact, we used Siemens, which is an awesome partner there. And you crash these cars, they instrument them like crazy. But what really is happening is the crash test people have modeled the car extensively in their systems and have crashed the car thousands of times on all kinds of manufacturing variances. And then you just crash the real cars to make sure the model is accurate. And it's amazing, actually. Their accuracy is incredible. We showed it at Pebble Beach. And then we take these engineering prototypes and you test them like crazy. You're just testing. So this was in a RF lab. This is another really cool thing. These are all over the world. They're durability tracks. They're cobblestone race tracks. And they have these drivers that jump in the car and they'll drive around on these cobblestone racetracks. And they also have these things which are like ladders that have been welded into the cement. And one of my engineers was on one of these, and he said when he hit that, he thought the car was just going to fly apart. The driver's in there driving, and he thought, this is it. The car is it's going to come apart. And then they hit a different section where all of these are offset by half a rung. And he really said, my teeth were coming out. I was sure I was losing my teeth. But in fact, they do it. They try to get 100,000 miles of wear and tear in 3 months, and 10 years of aging. The cars just fly apart. I mean, you find all the weaknesses in the design. They also go through salt ponds and sprayers just continuously. The drivers can only drive for 30 or 45 minutes before they get, they have to take a break, and they have another driver come in, or they'll get, like kidney damage. It's seriously. I mean, you think, imagine talking to these young guys and say, hey, do you want to drive like these super fancy cars around, on this track? And oh yeah, they don't know what they're getting into. That would just be miserable. So at this point, issues with the transmission were beginning to surface. So one of the things that we had outsourced, because it wasn't in our core competency, was transmissions. So given the amount of horsepower we could generate from our motor, we needed, in order to make our 0 to 60 4-second time and have a maximum speed of 120 miles per hour, even though we have this wonderfully long electric torque curve, we needed to have one shift at about 60, 65 miles per hour. And we thought, well, this is no problem. Gears have been around for a super long time. The car industry knows how to do transmissions. We need a manual transmission, a 2-speed manual transmission. We want it electrically shifted. There's lots of examples of that. All the race cars particularly are done that way. And it has to have what's called a parking pall, because electric cars don't have engine compression. So when you put it in park, you have to actually put something to stop the car from rolling. Every automatic transmission has that. Every component should be just off the shelf, should be no problem. These people put one together. They had made lots of transmissions for other companies. It just didn't work. It kept breaking and we couldn't shift. Actually, if you kept it in the high gear, it worked, but if you tried to shift it around, it failed. So this was really a problem. But we found another supplier for that. We signed a new contract, a much bigger supplier. We're now much more well-known. People are willing to work with us. This is it going through a salt bath, and they have these sprayers that come down. The cars are just continuously being beaten up. And we're showing it. That's Schwarzenegger there. He's not real tall, but he's really big. He's very... And then we also took it to the Arctic, or to Sweden, which is kind of the Arctic, I guess. And they have these test tracks where they do the cold weather testing. And the point of this particular set of tests was to get the algorithms that control the drive stability talking to the analog brake systems so that you can drive safely on slippery surfaces. And what you don't see here, these pictures are taken by the professional photographer for this test track, is that there's all these other cars queued up right behind it. So you have the new Volvo that no one has seen spinning out, and then they're digging that one out of the snow. And then the Ford goes, and then and then our car goes and spins off. And then while you're digging that out, the next one comes. The engineers I sent there said it was actually quite scary because these cars are totally out of control. So I sent my little team, and they sat there with their laptops, and they would just sign up for each successive. They would sit there and fiddle with it, and we had instrumented a lot. But also, electric cars have a lot of data. Because unlike in a gasoline-powered car where you're sensing what's going on, you're trying to determine the fuel flows and you're determining the temperatures and stuff, electric cars, you're synthesizing the waveform directly in software. So you know exactly what you're doing with currents and torque. It's not guessing, you're not measuring it after the fact and trying to figure it out. You know exactly. So, my guys went clickety-clack, clickety-clack, and dialed it all in, and pretty soon, within a few days, or maybe it was within a week, they were driving around the track beautifully. So great victory. We come home, and both the ABS vendor and Lotus put an immediate red tag on the project, because that was supposed to have taken months and months. You're supposed to do that. You fly back to Stuttgart. You convene the committees. You get all of your 26 outsourced partners that did the electronics. And you sit there and work on this thing, and then you take those changes back to Sweden and you try again. And it's supposed to take all winter. And we had done it in 4 or 5 days. So it took us about 2 weeks to convince them that, in fact, it really did work. And that we just changed the algorithms on the fly and there's all this sort of set points you have to fiddle with. Because it's all in software. We can do that. We didn't have to change values or change the engineering. We could actually just do it in software. They had never seen anything like it. And this was through the whole car process. We had run into these things that were just incredibly slow. I mean, we were slow in our own way on other things, but the car industry, has 100 years of history, and sometimes it really gets in the way, and they don't understand Silicon Valley. I mean, it sounds like a cliche, but I think it's really true. We have a new design for the transmission, big giant vendor that's going to save us. We now are building what are called validation prototypes. So everything we've learned from all these testing is now going into the design, and now we're going to begin to build this is production intent with all the revisions, plus production process. Big step. We complete the first VP1, the validation prototype 1, in March of 27. We have 230 employees. It's gorgeous. The doors open and close, and the fit and finish is perfect. It is a production car, really. And of course, everyone knows what we're going to do. We're going to raise money. And again, raising money is always hard, but it gets easier. This really looked great. Everyone wanted to drive it, and we were making 10 of them, and we made them pretty quickly. we began to make motors in our Taiwan factory. We had the new two-speed transmission arrived really late, even for the accelerated, even for the revised schedule with our new vendor. That should have been more giant red flags, but we were kind of busy and didn't really, weren't paying as close of attention as we should have been. We shipped some motors, and then the final, in August, the last of the VPs are off the line. We go through the crash test. We passed all the European and US standards the first try with lots of margin. Again, the crash test modelers are just astonishing people. And we had the first measured car. Now remember, we had said it was going to be under 4 seconds by a spreadsheet we had done 4 years before. And there it was. I mean, it took a lot to get there, but it's amazing the power of math. You can sit there with that spreadsheet and predict what you can do $100 million later and 4 years later, or whatever it cost. But now we're in real trouble because we're doing those same durability tests on the cars that we did with EP1s, and almost everything is just passing like crazy. Things aren't flying off, everything is working great, leaks aren't happening, all the things we learned that first time, except every transmission that we have, whether we're testing it on the dyno or if we're testing it out on the tracks, they all failed, and they all failed for different reasons. This is really bad, because it was just one reason you could sort of fix it, but they had all failed. So not very good. By the end of the year, we had completed everything except the transmissions. We had complete regulatory compliance, everything was done, we had passed everything. We were ready to go. We had millions of dollars in inventory sitting there and no transmissions. So we came up with a plan we had to raise money now. Not a good time. We failed our big milestone. It's 2008. The markets are getting really squirrely. People are beginning to get a little panicked. We, in fact, right about this time, it was actually about 6 months before, Mayor Bloomberg came and gave us a visit. And he's really interesting and a fun guy, actually. And I'm with him, and I said, well, the economy, and especially in New York, and here everything's going really great. And he goes, well, I'm totally in cash right now. He says, people keep offering me prices on things which are insane. I can't make the numbers work. I don't understand any of the asset prices. So I've sold everything and I'm in cash. My friends think I'm crazy, but I think something really bad is going to happen. And I thought, wow, he's so paranoid. And then, I thought, that's why he's a billionaire, is that... anyway, it was really, really insightful. So we had to do a very expensive bridge round. Fortunately, people did, step up and keep us in business. But that was really tight. That was the closest I got. And that's about when I left, because we had a new plan. We were going to ship the Roadsters with the sort of broken transmissions jammed into one gear that didn't fail. But Moore's Law had come along in between. And so we had a way out of this. In that International Rectifier had just announced a new IGBT, and they were sampling them, and they were going to be in production in another couple of weeks, actually. And the IGBTs were more efficient. And the IGBTs are the little transistors that switch the power that goes into the motor. And we switch a lot of power. It's 400 volts at 1,000 amps when you're accelerating, more than 1,000 amps when you're accelerating. And you got these little pieces of silicon doing it. So any efficiency loss is immediately transferred into enormous heat gain. So the improvement in the efficiency allowed us to put a lot more current through those IGBTs, which meant we had a lot more horsepower on the motor, which meant we could go to one gear. So we had a new transmission design that was simply one gear and a parking pole. And we figured if we can't do that, something is really wrong. So we had a whole team spun up to begin designing this one gear reduction in a parking pole. When another transmission vendor came to us and said, we know how to do that. And we said, we've been burned now twice, we're gonna do it ourselves. And they said, we'll just provide you one on spec. And it was beautiful, and they supplied us the rest of the time. It was perfect the first time. But that was, that was a little bit later. So my team was largely done. We were just transitioning into the sedan project. Engineers were rolling off the Roadster. There was a ton of stuff still to do on the Roadster, but the design teams were beginning to really think about applying everything we had learned onto the sedan, which was the next big project. And quite publicly, Martin, my co-founder, who had been CEO, got ousted, and it played out in the press kind of badly. It wasn't as bad, I don't think, inside. But by May, we had the new 1.5 drivetrain was being tested with the new IGBTs, and we had regular production actually was started. We had our first deliveries, which was incredibly exciting, and we actually delivered cars to our long-suffering customers who, they had waited like a year and a half longer than we originally had said, but they had stayed with us the whole time. They're an incredible customer base. We had our first retail stores, and by October, we had gone through 2 other CEOs in between. If somebody actually is following the history, they might remember. And Elon becomes CEO in 2008, and he had always been a tremendous advocate from the very beginning with our first as an angel investor. He had been on the board the entire time. He had been increasingly active and obviously was very helpful when both we had financial problems, because of the transmission, but also on the technical side. So he becomes CEO. How he's able to do that and do SpaceX at the same time is incredible, I think. But he's, I think, doing a great job at both. By March, the sedan is announced, and this is really beautiful. And the sedan was designed from scratch to be an electric car. And there's lots of differences that you take. The whole weight distribution is different. It was what we really always wanted to do, but couldn't do for the first car. The first car was all about our drivetrain, and we wanted the car thing to be outsourced. But by the time we had learned everything going into the sedan, we knew we had to actually take a bigger role in the actual design of the car. Now, I personally didn't believe we could build a factory. That was something that Elon actually had pushed for, because I thought the cost of that would just be prohibitive. But as things unfolded, we were able to get an extremely good deal on the NUMMI plant. GM's bankruptcy, which should not have been a surprise to anybody following the industry. I mean, imagine a company where for 30 straight years you lose market share. And your corporate performance is worse every quarter for 30 straight years, and nobody's fired. It's unbelievable you can do that. I like to say that they made a lot of really interesting decisions, whether it was crushing the EV1s or abandoning their hybrid project the year that 6 months before the Prius came out, saying that hybrids would never go anywhere. Those kind of decisions, at each crucial point in technology, it seemed to me that GM made the wrong decision. And you have to have processes in place to make that happen. You cannot do that randomly, because you get some right and some wrong if you just flipped a coin. But they didn't. They seemed to actually know and make sure which ones they chose. Anyway, so they went bankrupt, and we were able to pick up the plant. And Toyota was thrilled to, I think, get rid of it too. By June, we have 1,500 Roadsters out there, which was pretty much our total production we'd ever, expected. We had the pre-orders for the Model S, which were coming in at a really fantastic rate. We acquired the NUMMI plant, which is the GM Toyota plant that is where the Teslas are currently made, and we had the IPO, which was fantastic. And by June, 2 years later, the deliveries begin. This is one of our first customers who's very excited. And that's actually, I think, the very first one coming off the line there. And 2,000 employees, 10,000 pre-orders. It was all looking good. And then today, for those of you that are still, or haven't been following Tesla, they repaid the DOE loan 10 years early. There's 25,000 cars a year being made at the NUMMI plant here, employing 4,000 employees. Very nice market cap, and they just announced this possibility of a gigafactory. It's all about the batteries, and they have sufficient scale to influence the battery design in a way that we couldn't do it originally with the commodity cells. So it's very exciting. I don't know, how that will play out, but I think it's potentially really a big deal. But now let's go back to what I started the talk with, and that is, did this really solve anything? So we know we had an impact, because remember, every one of our potential competitors, every car company on the planet had said that EVs were dead. They were never, ever going to do this again. They fired all their people. They got rid of the technology. They crushed the cars. They pulled them from museums so nobody would know that they ever tried this. And it was great, because that gave us this market opportunity. I have to say, I expected them to respond very quickly with lots of great technology the moment they saw it was possible. And they're still trying to figure that out, which is okay. But Bob Lutz he's a famous character in the car industry, and he came up with the Volt, and he pushed for the Volt project, and there's lots of funny stories around that. But he told us in private that it was because of us. And then, to GM's utter horror and dismay, at the automotive press lunch that they do every year, he told this story about, he came in and there was a press release from our Roadster, and he slammed it down. He was running the advanced R&D group, and he said, "What the hell is this? Tesla can do this, and we say it's not possible. What is going on?" So that's when he launched the Volt project. So I do feel that even if these car companies don't have the best technologies yet, we did spur them into doing it. The Nissan Leaf as well, comes from a slightly different lineage, but I think we pushed that as well. If you look at barrels of oil saved just based on average driving and the number of cars out there, we're up, 10, 15 million barrels a year not being consumed. Remember that the world uses about 85 million barrels per day in driving. So we're really actually the proverbial drop in the bucket. But it is showing a path. It is possible. We know how to do it now. I was asked when I was asked to do this if I had any sage advice for the entrepreneurs that had kept their hands up. So I'm going to start with the first thing, and that's pick a meaningful problem. And it doesn't have to be one of these really big, hairy problems. It has to be something that you care about and that you can get others to care about. Because it really is difficult to do alone. You need all problems now are big enough that you need to have a team. And if you can't convince anybody of the passion of your idea, I think you're going to be in a world of hurt. We had so many engineers come to us and say, "I want to work for you." And I'd say, "Well, I don't really have any budget." And they say, "I don't care. I want to be part of this." And we picked up some excellent help very early on because of people believing in the mission, even when we really could hardly afford to pay them. They were willing to take a lot of sacrifices. Even after talking to their spouses about it, they were able to do that. And again, you can't do it alone. You've got to have that team. The problems are just too big. There's also, if you have some great idea that you've spent years working on and you haven't been able to convince anybody that it's a good idea, there may be a reason for that. And I hear these entrepreneurs all the time that have these stories, and I think, there may be, maybe that idea is not such a great idea. Pick a great solution. We really researched and made sure that from all possible angles, we believed that the electric car was a great solution for what we were looking for. This was just recently, this is only a couple years old. Look at the expressions of the people in the pod car or whatever. Look at this thing. These are not great solutions. No one is ever going to drive these things. I don't know. Why they want to make cars that look like goofball things, I don't really know, but it is true. But you got to have, whatever the product is, it just has to be, it has to be good. It has to be better than what's out there. And in this case, it's got to be better than the gasoline cars, not just because it doesn't use gas. It has to be better. It has to have better acceleration. It has to have a better experience. And this is the thing that really, I think, is important in Silicon Valley right now, is don't worry if some of these solutions are going to be expensive, right? You're going to have to actually raise real money. It can't just be an app. I want to remind you, though, at the same time when we were desperately trying to raise, 100 million, Groupon selling, discount coupons by email, burned through like $1 billion. So, it's not always these software companies that are so capital light, but if you have a compelling idea, I think it can be funded. So when we were trying to get the ebook funded, we had Yahoo had just gone public, and the VCs were intoxicated by the idea of these web pages. And we would show our little ebook prototypes and our vision of selling this product and then having recurring revenue and having this encrypted, copyrighted, DRM thing, which at the time was novel. And we're going to use the internet, which was kind of novel too. But it was all dial-up modem at the time, pretty much. And we had VCs say, and this one particular one told us, we are no longer investing in companies that make products that people buy. That business model is dead. Fortunately, we found enough other VCs that thought that perhaps there was still value in making a product that people wanted to buy. But that was the minority. I mean, we really struggled. We had to use corporate, VCs basically that had industry interests, that were strategics, because the VC community at the time wasn't investing in anything that someone had to buy. It all was eyeballs. And they would say, well, can't you just do this as a web page? No, it actually, if you're reading a book on an airplane, it can't just be a web page. We didn't have that technology then. So what I'm saying is you can find the money if it's a compelling idea, a compelling team. It does work. You just have to work. It's harder. Apps are great, but they can't solve all these problems. And then finally, in this next 50 years, we're in a new time that we've never had in our lifetimes, in that, for the first time, we're going to actually face resource constraints. For 500 years, we haven't had any. We've always not run out of anything. And in these next 50 years, we're going to pass through peak population. We have actual supplies of elements that are only made inside of supernova, so we don't want to do that to get more. And they're running out, and we're consuming them and not reusing them. So a lot of industrial processes that make all these products are going to change. We'll have exactly perhaps the better, fancier products, but the way that they're going to be made is different. And it's already happening. Certainly the plastic, the early chemicals in the plastics have already switched, because it's getting cost effective to do something else that's actually sustainable. Every aspect is going to have to be sustainable. And in fact, companies that are public especially, I think in the near future, are going to have to say what things they're doing that are sustainable and what aren't. And the markets will price that in. So, it's perfectly reasonable to have unsustainable things as long as you have a plan to either make it sustainable or just go out of business and extract as much value as you can. But you got to disclose it to the investors, and it'll get priced appropriately. So the cool thing about this for the entrepreneurs is that almost everything is going to have to be rethought, and is being rethought at every place along the value chain, from the ore to the final product. So we're going to reinvent everything, and that has got to be the biggest opportunity possible, because we're going to have the richest, most insane economy, and we have to reinvent everything. So with that, thank you, and I think we're doing questions.
Yeah, Mark, thank you so much. You are just spectacular, unstoppable,
Well, yeah,
energetic,
thanks.
scrappy, resilient, resourceful. So we have some questions. So some of these questions were submitted in the email or in the registration online. So let me go through some of these, and then we'll open it up to questions in the audience. And we have a couple of microphones, and when we get to those, we'll go back and forth. So, Mark, did you ever think about producing a Tesla electric motorcycle?
Yeah, that we did, especially at the beginning, and the market just wasn't that interesting. There's lots of electric motorcycle companies now, and some of them will actually get it right. Electric motorcycles will take over, but they haven't quite got the formula right. They're not better than the gasoline equivalents right now, and that's a problem. It has to be better.
So intellectual property. What role did utility and design patents play in Tesla's financing and strategic partnering?
So in fact, the patents didn't play a very big role in financing. We patented everything that we thought was novel, but electric cars have been around for 100 years. 100 years ago, there were steam-powered cars. About a third of the market was steam, about a third was electric, and a third was gasoline. And I wasn't really sure which one was going to win. In fact, we named all of the conference rooms at the Tesla headquarters after failed electric car companies from the 1800s. And we had these beautiful ads from, we'd bought these ads from eBay, the original prints of these ads. So the patent landscape, the big patents, you're not going to be able to get because those were patented 100 years ago. We have lots of patents around motor design and battery packs and stuff, but it wasn't actually nearly as big. For the ebook space, which was much more virgin territory, the patents were a much bigger deal because nobody had done it before. Electric cars, people had kind of done before.
How did you first become interested in producing and marketing electric cars?
Well, part of it is when I was in Saudi Arabia, the amount of treasure that is sent to the Middle East to supply our oil addiction is astonishing. And it doesn't necessarily do good things there, and it doesn't do good things for us. And that kind of got me thinking that oil is not so great. So then when we were looking around, and I will say Martin was the one who proposed, let's do oil. It did resonate with me a lot, because I believe we need to stop using that stuff.
So early on, how did you handle the times when you ran into serious roadblocks, whether it be roadblocks in technology, for example, a battery, or in competition, or the press, or funding, or morale, or the regulatory environment?
Well, part of it is that you got to have a team that is different enough from you that you never are emotionally synchronized, because startups are really manic depressive. So you come and like some mornings that it's over. It's just impossible. You're never going to do it, and then other days that you're going to be bigger than Microsoft by next year, and you need to always have at least some members of the exec team on the high when you're on the low. Otherwise, if you're ever synchronized, it's over.
Yeah. So, yeah. And what, you have a little flag on your desk. It's green for when you're up and red. Yeah.
Actually, at the previous company, we had something similar for this.
Yeah. Okay, so I'm going to combine these two because they're very similar. It's been said that the urge to quit is greatest just before success occurs. And did you ever think about quitting during the early days of the company? And how did you get yourself through this period? And what was there one thing in particular that kept you going?
Well, again, it goes back to the team. I mean, it was always a really fun place to work, even if it was a lot of work and a little bit crazy. So the mission was always compelling, and I remember actually driving in one day where it was just meeting after meeting after meeting, and it was all bad news. And I was driving in, and there was a thing on NPR about some new global warming information, and I thought, wow, we really need to do something about that. I said, I just need to get through these meetings. That's what I'm doing. I'm actually doing something about it. So that helped, and keeping everybody desynchronized emotionally is important. I really, if you get the whole exec team, drinking at the wrong time, it's really not good.
Yeah, the Kool-Aid.
Right?
Yeah. Please comment on the interpersonal dynamics and how various founders get along in the pressure cooker of a startup.
So that's an interesting question. For the most part, everyone gets along pretty well when there's only one vision, one product, one thing to do. So at Tesla, we had obviously some very public sort of falling outs, but for the most part, everybody did, worked really well together. At our previous company, everything worked well until we started having multiple products. And then it became much harder to keep everybody on mission, because when you only have one thing and you have to get it out on the market, it's very easy to kind of keep everything, rolling along. When we had multiple things in multiple markets in different countries at our previous company, it was difficult. So we were kind of sensitized to that. And, we kept resisting temptation. So the electric bikes, we had electric boats that came. We had lots of opportunities to go off in different directions. But we didn't do that because we had to stay absolutely focused on the one core mission of getting the car out. And that kept everybody in pretty good stead.
Focus.
Yeah.
Yeah. So maybe some questions from the audience, and maybe we'll start. Who's got the mic?
Yeah, you must have a mic.
You got to have a mic. So Dan will walk around and hand one to this gentleman in the blue shirt. So stand up and announce yourself. And
Sure. I'm Aditya Nandluri. I work at VMware in analytics. What do you think is the main reason Fisker went under? So what were some of the missteps that they did that Tesla did not? Or maybe you guys did and you guys got through it?
Well, they had an artist as the CEO. I mean, Heinrich Fisker is probably the best car designer, or stylist. He's not an engineer, he's a stylist in the world. And he was running things. And the thing about artists, I mean, in general, and the stylists, is they want these beautiful things. And then the engineering team comes back and says, well, that's great, but no one can get into the car. You have to have doors. We have to be able to get in. And literally, I mean, the Fisker actually suffers from that. It's got this road injury. So, and when Heinrich was the CEO, there was no one, in my opinion, I don't know much about the internals, but there was nobody to fight back and say, You got to have room for the batteries. You got to do this. You can't, I know it's going to mess up the beautiful line, but it won't work unless you have that. And there was nobody to push back. And I think that was their biggest problem, because the car is beautiful, but it didn't drive well because the engineers didn't have the clout to fight back.
Yeah, so maybe a question from here, right?
So I hadn't realized that you guys got some money from the DOE, but I certainly realized that Solyndra got a lot of money from the DOE. Why is there such a difference in the public perception?
Well, because one made money and one lost money. I mean, that's the, Solyndra, I don't know much about, Solyndra. I think that they failed to anticipate where prices were going to be. So by the time it came out, it was a great solution, but they were still too expensive. Tesla, sold the cars that they said they were going to, and were able to pay back the loan early. I don't know. No, the press is the press is very well. In fact, one of the things that happened when we got the loan is we were attacked for being a British company that all of the employees were in the UK building sports cars for rich Europeans, and that was where the federal money was going. And since it was a Silicon Valley company, we did have about 20 employees in the UK, or maybe about 10, I guess, at that point. And none of the money had anything to do with the sports car at all. And it was all going to be invested in a factory here in California. It was like the weirdest, if you just looked at the public documents, you'd know that it was wrong. I don't know why we got beaten up so much. We got beaten up quite a bit initially. But once you're employing people and shipping cars, everyone forgets that.
I'm Jim Lovewell. I work for Define Inc. We're a medical company. You talked about sustainability, and I'm kind of wondering, if China produces 20 million cars and we produce 14 million cars, are we going to have enough lithium?
Well, lithium is a funny thing. I think we'll have probably enough lithium. So, if you look at the early pictures of how mining of copper or any of these elements were done, like copper, people picked up copper ingots, in the desert with mules. I mean, and now you remove mountains and you get little tiny amounts of copper. Where we are with the lithium supply, to my understanding, from the pictures that I've seen, is we still are using people with shovels in dried up lake beds or originally seabeds in the Andes and some other locations where it's concentrated very easily, and literally with shovels into wheelbarrows. So we have a long ways to go in terms of lithium. The other thing is that lithium-ion batteries are totally recyclable. And in fact, not so much for the lithium, but because of the cobalt that's in them, they're profitable to recycle. They're like aluminum cans that way. So we will get most of that back. So I think they'll be fine.
Sunil Vemuri from Recall. You talked earlier about the things people like having solar panels on their roofs. Can you say a little bit about what secondary effects from Tesla's success has happened? Are you seeing other industries also picking up from or any evidence from your successes?
Well, I don't know. I mean, there's some weird secondary effects which I think could be really neat. The more electric cars that are out there that are plugged into the grid, particularly at night, you can do some really great dynamic load balancing on the grid if you have the protocol set up to do that. So I'm not sure exactly what you mean in terms of seeing other industries, but I think that one, the electrical grid is not particularly stable. I mean, especially with renewables. And I think actually electric cars have a role to play there because they're big loads that are plugged in. Just sitting there, because you charge at night, right? So you plug in at night, and then in the morning you wake up and you have your full charge. You can imagine the grid saying, hey, the wind is blowing. In California, the wind tends to blow at night, which is when we don't need any of the power. Charge up like crazy. Go for it because we have lots of power right now. So there's a bunch of players around that, and I think that things like that are going to be real. And I think an awareness of what's possible. I mean, it certainly affected the car industry, which is good.
So there were some in the back there?
Yeah,
They-
Tesla has announced a strategy to swap out batteries. Do you think that's a real strategy, or is that PR to combat perceived range anxiety or something else?
Well, that's a really, really good question. I do not believe in battery swapping outside of fleets. There's lots of reasons for that. And, you know, Shai Agassi, you know, he did this very famous Better Place experiment at great cost about swapping batteries. The economics of it just makes no sense. You're only transferring a few dollars worth of energy in a very expensive battery pack that is incredibly heavy, that you don't really want to standardize at this point. I mean, just like the fuel tanks in modern cars are all different. You don't want to have that be some commodity. And then they differentially age, you know, like somebody, you don't want to get a pack that's had 100,000 miles on it and you've got a new one. I just don't see it ever happening. The only difference would be if you're in a fleet perhaps and it was all captive, maybe it would work. I think it's interesting, but I don't think it's particularly useful. I may be wrong. I don't know what the total strategy is. But.
yeah, maybe in the back, way back there.
Hi.
A couple
You
quick
mentioned
questions. Oh, I'm sorry. A couple questions. First, when do you get across the billion-mile mark for electric vehicles driven? And second, who does Tesla see as their primary competitors?
Well, you know, actually, the billion-mile, I don't know. That's a really good
I
question.
suspect it's this year.
It could be. I mean, you know, there's a lot. If you look in the sort of Silicon Valley, I mean, oh my gosh, we've got so many electric cars, both Teslas and Leafs and everything else. In terms of the competitors, I think that the big guys, if you will, the existing incumbent players, will eventually figure it out. You know, I never imagined it would take this long. I couldn't. I mean, imagine if you were, you know, a computer company here, and you know had some you just wouldn't. You would fix it really quickly. And the car industry has been incredibly resistant to it. I think partially because they don't really have any electrical engineers like we would consider electrical engineers, and they've been doing the same thing for so long. So I assume that the incumbents will eventually have compelling cars, electric cars. I just have to believe that that's going to be possible. I haven't really seen a lot of evidence yet, but they've got to catch up eventually.
you mentioned that you learned a lot by doing dry runs with VCs that you didn't think would invest. What kind of things did they tell you? What kind of feedback did you get from them?
Well, the VCs, especially if they know they're not going to invest and you're asking them to ask lots of questions, they were quite good about asking, for example, how the distribution system was going to work. And then when we had an answer for that, and they really pushed on that, and they said, how much do you really know about how the distribution of cars works? And in fact, we didn't really know what we thought we did. One of the VCs connected us with somebody who had been a very prominent car dealer. And it was one of these great things. I think it was probably, that VC had dated somebody who, knew somebody. It was, one of these great stories. But by talking to them and understanding how the franchise model worked, we completely changed our distribution strategy because we realized that that was a mistake. And if we had gone down that path, you can never correct it. It's a one-way path by law. So once we figured that out, we distributed differently. That literally changed the whole distribution strategy. That was an example.
So maybe down here in the front.
Thanks. Rahul Bahadur from Checkpoint Software. Just wondering, what do you think is the time frame for the charging infrastructure to get up to usefulness?
Well, so the charging infrastructure is a really good question. So one of the things we decided to do at the beginning was make sure that we didn't need to have a charging infrastructure. So, fortunately, electricity is really available everywhere in the States. And we wanted to make the range long enough that as long as you could charge where you slept, every morning you have a 200 and some mile range, and most people don't drive more than 50 or 80 miles in a day, or even 150 miles is kind of a big day for most people. And we wanted to make sure that as long as you got home, you would just wake up and drive again. and you'd never have to stop at a charging station anywhere else. You'd never have to stop at a gas station. And for Teslas, that is true. Now, some people will say, well, wait a minute. When I'm down in Palo Alto on a Friday night and there's no parking anywhere, those EV spots are filled with Teslas all plugged in. That is true, because if you're not plugged in, you get a parking ticket. And I can, the first time I saw that, while I was, I have to say, looking for a spot in downtown Palo Alto on a Friday night, and I said, oh, there's a whole bunch of EV spots only. And I went there and they were all filled with, and I was like, how far did these people drive to get here? I mean, they came from, Sand Hill Road to get, so I don't know if the public charging infrastructure actually has to be very advanced at all. You have to have them where you sleep. So hotels and stuff need to have some kind of 240 volts you can plug into. And a lot of hotels do that because it's not very expensive to put in some 240 outlets in the garage. The thing that it does allow, though, is it makes viable cars that have much shorter range. So the Nissan Leaf is viable because it only has a 60 or 70 mile range, really. But that's okay because there's so many chargers now. So it could enable an entire different kind of mobility, a different kind of car. I actually think it's transitional. I think the batteries will simply get good enough that the ranges will be long enough on people's cars that they won't use the public infrastructure, that really they'll just charge where they sleep. And on the streets of San Francisco, they'll have to have some plugs because a lot of people don't have garages. But they do that in other countries where it's really cold. All the parking meters have plugs in Nordic countries for that reason. They have to heat the engines, the engine blocks.
And how long do you think it will take till the batteries are that good?
Well, I don't know. Batteries get better at about 7% a year on average. So it's doubling about every 10 years for any given price performance, kind of ratio. And there's always the hope of a step function change. Right. There's lots of startups here in Silicon Valley looking at different kind of anodes and cathodes and electrolytes. And each one of those promises some kind of step function improvement. And if any one of them works, the game really changes very quickly.
I'm Subra from Applied Materials, and my question is related to your battery chemistry, dollar per kilowatt hour performance moving forward. What Tesla thinks about bringing disruptive technologies in bringing down the cost. Right now, say for example, from NCA chemistry, are you looking for different chemistries, or different platforms, or different cell phones?
So I can't speak for what Tesla's doing now, and obviously they have this Gigafactory idea. Where they have some plan to reduce the cost per kilowatt hour of storage. In general, the batteries get better all the time. The Panasonics of the world, actually, Panasonic's probably the world's best battery maker at the moment. They're always tweaking the chemistries. As I say, there's a lot of technologies out there, all the way from solid-state electrolytes, which are kind of interesting, to really fancy anodes and cathodes. I don't know which one's going to win. I went to a bunch of these electrochemistry conferences, and I discovered that nobody actually knows how the batteries work, which I was blown away by. And then a friend of mine who's a very well-respected solid-state physicist said, she was like, oh, well, no one knows how silicon works, and we've been studying that forever. But it doesn't prevent us from making Pentiums, So, somebody, I don't know, I have no idea. There will be advances. It gets better every year. There's roadmaps that go off, to another doubling for sure.
So we have time for one more question. So Norm, how about we get Norm here?
I have just one quick question.
You gotta have a microphone. Yeah.
It's probably a big one. This is Maritza from Cleantech Open.
Go ahead.
So
Maritza, and then,
what is the
Norm.
shift that has to occur in the marketplace for their consumer mentality, for there to be greater demand for these types of cars?
Well, at the moment, I think that there's actually quite a lot of demand. Mm-hmm. One of the things that we wanted to do, even from the beginning, was make the car be a really great car, so that it would be aspirational. If it was likely the price point would be such that it wasn't going to be accessible to most people, but we wanted to make it aspirational, so that if you saw, electric cars, remember, they were the goofball cars, right? You saw what they used to look like. And we really wanted to make sure that people would say, when I win the lottery, I'm going to get myself one of those electric cars. Because that's, even if they couldn't afford it right away. So I think the mentality maybe is getting there, especially since, there are a lot of them around. the big difference, I think, is going to be the price point. It isn't so much about the price point to save gas, it's simply that it has to get down to a reasonable, a $30,000 car that can be electric with a really good range. And we're getting there. Every year it gets better. But it's going to be, probably a bunch more years before that happens. I think that the moment there'll be this tipping point where suddenly the price is close enough and everyone goes electric, because driving an electric car is really fun. It is way more fun than a gasoline-powered car. We had a person who drove one of our Roadsters, and really early on, and we were showing him the car, and he gets back, and we thought it went really well, and he calls from gets in his Porsche, and he drives away, and he calls from his Porsche, and he's furious on the phone, and we're like, God, what's going on? He says, what have you done to my car? Okay, I spent $250,000 on this car, and you've ruined it. Because his Porsche no longer was compelling, because that acceleration wasn't there, that instant response. Electric cars are really, really fun to drive. So once the price gets to anything that most people can afford, I think they're going to just take over.
They really are fun to drive. I drove the Roadster up 280 one day, and we were going 70, and I leaned over to the other guy and I said, can I punch it? It was a Tesla.
Mm-hmm.
And he said, go ahead, go for it. And I hit it, and it just took off. It was just like it was going 0 and it was just unbelievable. Yeah, absolutely unbelievable.
In fact, one of the car and driver, when they took one of the cars away, and we had never had that happen, and the magazine came and they instrumented the whole thing and they drove it away. And the guy comes back and he says, it was the editor for Car and Driver. I think it was Car and Driver. It was one of those big car magazines. And he said, well, it's really interesting, it's neat. What's your top gear performance or something? It's like from 30 to 80, or I can't remember and it's not a metric that we kept. We had no idea, And he said, well, we'll look at the accelerometers. I have to look at the database back at the house, but I'm pretty sure it's the fastest car we've ever driven. And we were like, and that was, in fact, it was in the article. They said it beat the Veyron. I think it was the Veyron had just come out. And that particular range where you're going, 30, 40, then you punch it, it was faster than that. Now, obviously, the high end was a different story, but nobody goes more than 100 miles an hour. I mean, that's the case.
Yeah. So last question,
Okay,
Norm.
perfect last question. So, Mark, you left Tesla almost 6 years ago. What have you been doing? And do you see yourself as starting another company, or it's enough?
Well, I mean, it's kind of enough at the moment. So I have 3 little kids, and I was in startup land between the first company and the second company and Tesla for well, it was like 11 years. So with my third kid being 2 years old, and the Roadster was kind of another kid in a sense, and it was going out the door, I was ready to stay home. Now I got elected to the school board, so I'm actually one of those politicians in your community that sits at these endless meetings in the school board and tries to do stuff. And I do all kinds of stuff with the kids. So at the moment, it's really great. Now, as the kids get older, that may change, and I've only been tempted a couple times in the last few years where I just think, an earlier me or a later me, I would go for it, but I can't do it right now. So Nuvo Media, great story, $170 million exit, one, right? And then Tesla, more than $25 billion market cap, IPO, another one, right? So I'm going to come back and do a hat trick, right? Yeah, maybe.
Yeah. Great, thank you so much.
All right,
Thank you so much.